with a guest lecture, Dr. Hsin-Liu. She's the founder and directs the Hybrid Body Lab, which invents culturally inspired materials, processes, and tools for crafting technology on and into the body surface. She will talk about her research, the lab, and we are very excited because 2 of our workshops this week are about biomaterials and wearables, second skins. So our students and I think all our community will be very excited to hear Hsin-Liu and what she's talking about. So without further ado, I leave you the floor, and yeah, thank you.
Awesome. Well, thank you so much for the intro and for having me. So again, I'm Hsin-Liu. I'm an assistant professor at Cornell University, where I also direct the Hybrid Body Lab. And here you can see on the left some highlights, snippets of projects that my lab works on, and also the team of researchers on the right. And we really focus on creating what I would like to call hybrid skins. So these are an emerging form of conformable interface, and thinking especially about how we can invent different types of materials, processes, and tools for crafting technology and soft interfaces on all different sorts of surfaces. And the work that I'm presenting here today is the collective work of my entire lab. And we are really a group that comes from a wide range of disciplines. And I also hope through my talk today to just shed light on the importance of interdisciplinary collaboration for this type of work. And the lens in which I would like to talk about my lab's work today is by looking at these hybrid skins as a sort of conformable interface for living with, in that I think they really have a high potential to be embedded into our daily lives. And so what we're seeing here are 2 seashells. However, these are not seashells that are just found in nature. They've actually been crafted by the human hand more than 40,000 years ago to be worn as jewelry to decorate the body. So I really think it is a very innate human desire and fascination to use the materials around us to alter our physical appearance. And this fascination has been evident throughout the entire human history. So there's really no culture and no period of time in which humans have not sought to use materials around them to change the appearance of their bodies in some form or the other. And so here I'm showing some examples in different periods of time, but also from body crafting practices from different geographic regions and also different cultures. And so often by changing our physical appearance, we also in some way construct and build our identities and belongingness to certain cultural and social groups. And today, with the potential to also integrate technology into this palette, I think this the function of doing so becomes even more interesting. And we're now at a very interesting place and time where technology has become so miniaturized. And the breakthrough in novel materials has really also enabled technology to become so slim and also conformable that we can really start looking at these emerging technologies also now as a material to craft our bodies. And while our lab, a lens that we take very importantly is through the technological development and thinking about how we can enable technology on the body. A unique lens that we also like to take is to think about the greater cultural and social context when we're designing these devices, because we know that anything that's worn on the body cannot be separated from the context in which we as humans go through every day, our society and our everyday interactions. And so in designing these hybrid skins, we really think that technological developments, especially the most emerging forms of technologies, including some of the ones that in the Transmedia summer school you've all are exploring. And in developing these technological development, I think it's very important to bridge it with cultural practices, especially in the context of slim and conformable interfaces. And we really think that this relationship between technology and culture should be like a spiral staircase where they can inform and build each other up. And we call these conformable interfaces hybrid skins because they're often hybrid in their integration of technological function with cultural considerations. And often the resulting skin, it often can also serve hybrid purposes, of course, of belongingness to certain cultural, social groups, signaling our identity, but also technological functions that may not have been possible prior. And so the first set of projects that I would like to talk about is a range of hybrid skins that we created that take inspiration from existing form factors in which people have been decorating or crafting their bodies for a very long time. And I like to call these culturally inspired form factors. And some of the forms, for example, as you can see, that we drew a lot of inspiration include temporary tattoos, skin stickers, and even more basic form factors such as powders and gels. And one project that we started with was looking at the cultural body craft of metallic temporary tattoos. And so in this project, Dual Skin, we're interested through the hybridization of metal leaf, which is a conductive material, to make temporary tattoos that are now also conductive and also can have extended technological functions. And we can see here some examples of dual skin devices, including using it as an input device, an output display, and also here as a wireless communication NFC, and also for aesthetic purposes, etc. And so after the foray into this first project, we also started to think about, would it be possible to create more complex circuitry that can go on the skin surface? And this is what led us to this next project called Skin Wire. And so the goal of this work was we were really interested in thinking about how we can pattern a lot of large amounts of complex wiring on the very limited surface area of the hands and fingers, which are also extremely dexterous. And we took a lot of inspiration from this body craft of hand art. And this is a cultural practice that you might see sometimes on Instagram, TikTok, and even on some fashion shows in which these body artists, they take intricate amounts of wires and they pattern it in very intricate forms for aesthetic purposes. However, in this project, we thought of integrating braided enamel copper wire. And through braiding, we were able to integrate multiple wires into one strand. And therefore, as the device you can see here is a index finger and thumb-based IMU sensing interface, which actually consists of 16 wires. But because of this culturally inspired approach, we're able to drastically simplify it and to create this fully integrated hand gesture interface. And you can see that it's untethered. There's nothing, no huge battery or extra processing hiding under the sleeve. And so after thinking about and taking inspiration from existing ways of decorating the skin, we started to think about the face, right? We interact with each other, we see a lot of people's faces, right? However, it's really a more underexplored area for soft wearable technology. And so in this project is Lucent, which was led by my student, Elle Lowe. So Elle, she has the daily habitual practice of wearing eyelid stickers. And you can see an example of these on this image on the top left. So these are essentially these little stickers that you can stick onto your eyelid. And we started to think about if we might be able to technologically hybridize it by coating a layer of conductive polymer, so that now these eyelid stickers can actually become capacitive touch sensors, right? Through blinking, and by detecting the motion of blinking, the activity of blinking throughout time, and through relevant machine learning, would it be possible to then detect the activities this person is engaging in, for example, if they're resting or working, and to then connect this to maybe some personal assistant, apps, etc. And so this was a really interesting also project for us in looking at a cultural form factor that's on the face. And so after looking at these projects, which consists of more of a skin layer, right? A second skin layer. In this next project, Skin Morph, we started to think about if it might be possible to take inspiration from more, I like to call more basic or primitive form factors to decorate the body. And this includes gels and creams and makeup powders, right? And we can see that these are all a form factor that also remains highly underexplored. And so in this project, Skin Morph, we took inspiration from the form of cosmetic and gels and creams that we often adopt. However, through a technological hybridization of integrating hydrogels, we created a interface. Essentially, I like to call it a second skin armor that's able to selectively transition between a much more soft and clear state on the left, and when it's heated, it becomes stiff and opaque. So through this reversible interaction, it is therefore programmable, and so you can then have basically a stiffness tuning second skin armor. And some applications that we explored, including one that we can see here, which is a more interactive cast for carpal tunnel syndrome. So it can maybe learn the patterns of individual wearers' hand motions and provide just the right amount of stiffness versus soft support for their healing. And this is another example of a dynamic foot protection pad when you're wearing uncomfortable shoes. So it can transition between soft and stiff when you're walking up a hill or versus when you're sitting to provide just the right amount of support. And so after creating the first range of projects in which we took a lot of inspiration from existing cultural forms, we also got quite interested in thinking about how we might be able to create devices that can actually change shape or move on the skin. And to enable this, the Scott is really interested in looking at and designing robotic textiles. And in this line of work, we take a lot of cultural inspiration from textile structures. And so each of us today in this talk or watching this talk later, we're all wearing some form of either woven or knit clothing. And so weaving and knitting, they're the two main approaches to structure of fabric from a one-dimensional yarn, right? And there is actually a very, very rich historical woven and knit structures that are vastly used in crafting, etc., but have yet to be explored, we believe, in the realms of designing emerging hybrid skins. And so in this next line of work, we really took inspiration from a lot of these woven or knit structures. And I want to talk about some of our projects looking at woven structures first. And so weaving consists of two groups of yarns intersecting in a perpendicular angle. And because of this grid-like structure, woven woven interfaces are inherently very durable. And you can also see how this grid-like structure also lends itself very well for integrating circuitry. And so in this project called Woven Probe, we were really interested in thinking about if we could actually weave a complex interface that's fully integrated. And you can see here that this entire index finger and hand gesture interface, it is completely woven and also with integrated electronics. And showing here just like a quick demo of it actually working. And we also experimented with some very preliminary NFC energy harvesting through the NFC coil at the end. And in this work, our cultures were really stemmed from taking a lot of inspiration from culture-inspired weave structures. And for example, in creating this index finger and thumb-based hand gesture interface, we looked at a range of different culturally inspired structures. And for example, for the traces that go along the knuckles of the finger, we adopted this lace serpentine weave, as you can see here. So this is actually a hand manipulated weave technique called Spanish lace. And we adopted this because this mimics a lot of serpentine structures and soft electronics that really allows for much more flexion and stretchability, for example, for areas such as the knuckle. And taking advantage of the weave structure, because we were patterning, I believe, 7 or 8 individual flex circuit components into this weave structure. So the routing, right, between these individual islands is also very important. And this led us to also take advantage of the grid-like structure of weaving, right, to enable very systematic patterning, as you can see here. And last but not least, we explored a lot of more complicated circuit topologies. For example, in weaving, there's a practice called a double weave where you can weave 2 layers at a time. And this is something that we explored in experimenting with NFC tag. And in this project, it really gave us a lot of inspiration in thinking about the potential in using these textile structures to create even more dynamic hybrid skins. And in this next project called Patcho, which is led by my PhD student, Ping-Song Ku, what we did was we decided to weave in a shape memory alloy material into a range of different woven structures. And when the shape memory alloy is activated, it can then deform in a range of different ways, from shape change to even providing some very basic tactile feedback on the skin. And so after looking at weaving, I would like to now talk about some of the culturally inspired structures that we looked at through knitting. And knitting consists of a single thread, and it is in a loop-by-loop structure. And so because of this loop-by-loop structure from a single thread, it is inherently, the structure is inherently very, very stretchable and also compliant. And so here I'm showing an example of a work. This is by Zaha Hadid Architects, where they actually use a knit textile as a skin, right, for an architectural structure. So knitting really has this potential to deform and to conform, right, to different shapes. And looking at knitting in this project called Knit Dermis, which is led by my PhD student, Heather Kim, we were very interested in thinking about what are some underexplored knitting structures in which we can integrate these shape memory alloy springs. And by creating an array of these knitted skin patches, which are patterned with different pattern in different methods, right? with these shape memory alloy cores, when activated, they're able to actually create a range of tactile feedback on the person's skin surface. And because the knit textiles themselves are very, very compliant to the body, the sensation is actually very acute. You can feel it quite well. And after knit dermis, in this next project, knit skin, which is also led by my PhD student Heather Kim, we wanted to go a step further. So beyond being able to deform on fixed body locations, could we maybe knit something that with integrated actuators might actually be able to locomote? So for example, to move up a person's arm or body, etc. And so we can see here a demonstration of knit skin. And so this is a knit textile that is able to move on cylindrical surface. This includes our arms and limbs, but also cylindrical surface such as pipes. And we take a lot of bio inspiration from snake skin and the way that snake skins are patterned. And so what we do is we mimic the unique arrangement, right, of snake skin, and we create a knit textile. Also with these scale patterns, and they are able to provide directional friction to propel these interfaces to move in a certain direction versus the other. And so this enables a range of applications, from using it as a tree guard, for agricultural applications, for therapeutic rehab, right, as an interactive task, and also for pipe repair, right? So it can go into places that might be harder for humans to scale. And in this next project, Nedima, we're going a step further, taking advantage of the compliant nature of knits, and also their just accessibility for mass manufacturing, right? And we created a robotic textile for mobilizing hand edema. And so here you can see a demonstration of the Nedima device. So it consists of a glove, and through integrated shape memory alloy actuators, which they compress in a sequential setting, hand edema is mobilized, and with the goal of draining it back towards the heart. And so hand edema is actually a very severe condition affecting a lot of people in different phases in their life. And so we can see here are a pair of hands from a person, but we can see that on the right, what we can see on the right is an example of a more swollen hand that is suffering from hand edema. And we wanted to provide, through a knit textile, which also has the ability for sequential compression, an alternative to current conventional treatment methods, such as, for example, the most common treatment methods today for edema include wearing a pneumatic sleeve, we can see here. However, it is very bulky, and because of the larger form of the pneumatic chambers, it's not able to go on the individual digits of the finger. Another approach that is known to be much more effective is actually manual massage of these hand edema fingers by physical and occupational therapists. But we can quickly then see how this is very labor intensive, and it may deter a lot of people who do not have the same resources to get treatment for this very common disease. And so in edema, we were interested in creating a robotic textile that essentially, through sequential compression from the fingers throughout the palm to the wrist, that it can in some ways mimic manual massage from hand therapists, however, in a much more affordable manner. And we're very early in our in this work. However, we've conducted a study with 5 hand edema patients to understand the potential of this device. And we really think there's a lot of potential for these knit robotic textiles to serve as more personalized rehab devices for end users. And so after looking at robotic textiles, in which we take a lot of inspiration from culturally inspired textile structures to create a range of robotic and deformable closed body textile interfaces. In the last section of my talk, I would like to share some of our projects and thinking about how we can move towards more inclusive design for these emerging hybrid skin interfaces. And I first want to talk about some of our experiments and research and thinking about how we can democratize access so that more people can build and develop these hybrid skins themselves. And a lot of the motivation for this line of work came in 2016. And so this was after we released our dual skin project. We started to get a lot of email from folks who read our paper online, and then they basically followed the paper and they brought their own materials, and then they fabricated their own dual skin device. So here are some examples of, and these are people we've never met before. So we were really thrilled and excited to see this. And you can see on the top right, this is actually a student from the Stewart Elementary School who created an on-skin selfie button, which I think is very useful using dual skin. And so I talked to some of these people who use a dual skin product to ask them, like, to understand the usability, right, as a research. And one feedback that I consistently got was really the need for a modular kit so that it could be even easier and quicker to prototype these devices and also to iterate between these different ideas. At Cornell University, I also teach a course on fabricating and building on-skin interfaces. And the first time I taught this course was during the COVID-19 pandemic, the start of it. And so it was conducted online. And through a lot of the feedback also through this course, because while it's really interesting, right, to build a on-skin interface from raw materials, it is much more time consuming and takes more skill set involvement. And so I also got a lot of feedback that it would really lower the floors and make it much more easier for folks to get started if there was a modular toolkit. And this is what led us to create Skin Kit, which is the first construction kit for on-skin interface prototyping. And this work is led by my PhD student, Ping-Sung Koo. And so Skin Kit, it involves 2 main components. The first is on the left, you can see here these plug and play PCB modules. And on the right is the second part of the kit, which are these skin conformable wire modules. And the skin conformable wire modules can be patterned in different ways to create different circuitry routing. And then by placing the PCB modules in these flaps that sit between each of the conformable wire modules, through simple plug and play, an end user can very, very quickly have a circuit. And so through our studies, we found that people are able to create a on-skin interface in under 30 minutes. And so to just provide more details about the skin conformable wire modules. So it consists of 6 different wire module designs, and by combining them in different ways, they can have a much more complex or simple circuit layout. And the second component, the plug and play PCB modules, they have a modular sequence and they're pre-programmed. And so this is why when you stick them together, they can automatically start working. And here are our library of modules, which really to have a more richer library for folks to start prototyping with. And I want to show here example of actually building something with skin kit. You can see these are the PCB modules which are placed in sequence on a skin cloth layout. And so we can see here the user is changing the layout because they might want it to look differently, right, on their body. So we can see them using the skin cloth, which can be tessellated in different patterns. So you can see that with the second, they can have a different layout. And then by placing the PCB blocks onto the skin cloth, there you go. You have a proximity LED tattoo within minutes. And we ran a large series of workshops with both designers who maybe have very limited experience with technology, but also engineers and researchers to use this kit to create a project. And so here I'm just showing some highlights of the very diverse range of projects that people created with a very limited amount of time. And so you can see here someone created a wearable flashlight for safety, for example, when they're jogging at night. And here is a haptic breath trainer, which can be also integrated inside a mask. And this one on the right, this participant created a ballet tiptoe dance training skin interface. So basically it would detect how far your heel was from the floor. And then if it's not far away enough, it'll light up to remind you. Folks also explored using this for remote communication, as you can see on the bottom right, and also as a on-skin calendar reminder for important events. And so it was very interesting for us to see just a diverse range of applications that people created using skin kit. And so besides the approach of a construction toolkit, another approach that my lab is also investigating in trying to democratize on-skin interfaces is by using much more accessible materials. And one material that we became very intrigued by is actually paper, and more specifically store-bought washi paper. And so while we may not think about paper as a wearable material, something we can wear culturally, and it has actually been used historically as a material for wearing. And I'm just giving one cultural example. One example is the Nishijin textile in Kyoto in Japan. What they do historically, and they've been doing this for centuries, is they actually take washi paper and they shred it into these very, very thin strips. It is then woven into the weft of kimono fabric. And because of the more durable nature of the woven structure, it's actually able to stay in place very well. And so taking inspiration also from this cultural practice and also trying to take advantage of the accessibility, right, and affordance of paper. In this project called Skin Paper, definitely no pun intended, which is led by my PhD student, Jinwen Zhu, we developed a fabrication approach in which we were able to very quickly silicone coat washi paper, and then by shredding it into thin strips and then adopting techniques from paper weaving and basketry weaving, we were able to create a range of paper woven structures that can conform to a lot of different areas on the body. And here I'm just showing some examples. And in this study, we really sought to engage craftspeople who maybe have experience working with paper craft or with different types of weaving, whether it's basket weaving or textile weaving. but without prior engineering experience, to use this material to create something. And so we did 4 case studies, and here I want to show some examples of what they built. So this is one of our participants, Luna. So she created actually a 3D shoulder warmer, and another participant, Ruth, she wove a 2.5D light up bracelet. And Iris, she created a touch sensing harness using this more basketry weave structure. And finally, Scarlett, she created a 3D movement sensing device that went on her face using more paper weaving practices. So I think this was also really meaningful experience for us in looking at the accessibility of materials for democratization. And next, I would like to talk about using and taking advantage of transdisciplinary collaboration for inclusive design. And so while our lab, we initiate from a more engineering, computer science perspective, we found it just incredibly enriching to engage with experts in on-body design. And this includes fashion designers, artists who work on the body artists, special effects, makeup artists, tattoo artists, etc. And I want to first talk about a collaboration that we did with fashion designer Chris Evans. You can see him here. He is a fashion designer and creator of the brand Dine. And he was very interested in using our smart tattoos for his New York Fashion Week runway. So what we did was we created a series of NFC tags in the shape of his brand's logo, as you can see here. And the models basically wore these NFCs on their bodies, and it was a very interactive runway. So you know, the audience could take out their phones and to read information from the tags to understand how the garments were designed, etc. So it was a very interesting kind of like a deployment experiment for us to understand how the fashion industry would react to something like this. We also find it really important to also engage with the art community. And this is an example of exhibiting our work at the Center Pompidou in Paris. And by also engaging with the art community, but exhibitions, because they really bring in a much more general audience. And so we're also able to understand people's perceptions towards these emerging hybrid skins. And an effort that my lab is engaging in and very excited about is we have started an artist residency in our lab. And this was very much inspired from our prior collaborations with a lot of amazing on-body designers. Here I'm just a few of them who consulted for our projects or were active collaborators. And we think it actually is very important to engage the perspective of these experts in on-body design when we're thinking about how to create the future of technology that may go directly on the body, and to really go beyond the perspectives of STEM, essentially. And so in our artist residence, we ran our first artist residence last summer, in the summer of 2022. We had a special effects makeup artist, Morgan Chen, come to our lab, and she created, in collaboration with our lab and taking advantage of some of our technology, she created this moving face appendage.
Social prosthesis is a moving appendage. It's a soft prosthetic designed as two facial pieces that are made from rigid and soft structures. The soft skin of the prosthesis will curl and contract when triggered by a touch on the face. The name social prosthesis is a reference to Mimi T. Nguyen's 2003 essay, Queer Cyborgs and New Mutants, where she uses this term, prosthetic sociality, to describe the phenomenon of identity building in cyborg theory and literature. Nguyen refers to prosthetics in a broad sense as augmentations of the human body and self, and talks about how prosthetics extend past the merging of biological and artificial.
And so I think it was a very interesting experience for us to have a SFX makeup artist in our lab and to work with her and support her and think about how to integrate some of the new technologies that we've been exploring into also her makeup practice. And this summer, and actually right now in our lab, we are hosting a multi-disciplinary tattoo artist from Brooklyn, Joe George. And he has also created a series of just really very, very mind-blowing projects, taking advantage of some of the technologies. And while some of these projects are being finalized, here is one that I think is just so interesting of this, he calls this a snake skin that will basically change color like a snake when you're under the sun in different ways. And so through these projects, I think it is also a experiment for us to understand how to engage these on-body design experts with STEM, and what are some structures that we can develop to support this. And it has been a really interesting and fruitful experience for my lab to really think outside the box. Last but not least, I would like to talk about some ideas and efforts in thinking about inclusive design. So when we first started prototyping these on-skin interfaces almost a decade ago, we needed a lot of mannequin arms to test the devices on. However, at that time, online, we could only find mannequins in much paler skin tones. However, we know that this does not reflect the full diversity of the human experience, right? And we really think that representation is a really important issue. And so back in 2016, we actually developed an approach to create mannequin arms of different skin tones, because we thought it was so important to understand how these on-skin devices also look, right, and are presented also in public, right, to people from different backgrounds. And you can see how some of these issues start to mirror the concerns in the makeup industry, right? And so I think it is also very important for us in developing these devices to really think about these considerations. And so beyond the important issue of skin tone, there's also this question around social and cultural norms, right? So we know that people in different cultures can have vastly different perceptions towards something worn on the skin. Some can be very positive, some can be super negative. And so we wanted to understand this. And so in this effort, we ran a large-scale study in the US and also in Taiwan, which we use as a representative East Asian country to understand people's perceptions. And so we had people respond to a survey on a skin touch sensor that they could swipe on, as we can see here in this image. And this is an example of an interesting result to shed light on the importance of this. So in terms of preferred body locations for a interactive tattoo, close to 40% of participants in the US mentioned they would love to have this tattoo on their outer arm. And this is from a lot of our analysis, really because that this is a very common tattoo art location in the US. However, in Taiwan, we learned that a lot of people would actually not want to have tattoos in this location, but instead in the inner form, because it was much more discreet. And so, for instance, when they were going to work or when they're with maybe more elderly members of their family, they could block it with their clothing. However, when they were with friends, etc., folks they would want to share this with, they could actually show it. So I think there's a lot of very important cultural considerations for us as researchers to also understand in designing these devices. And so today, I hope that I'm providing a very, I would say, quick walkthrough of some of the main approaches that my lab has been taking in designing hybrid skins. I really hope to provide a lens and thinking about how in designing these newest forms of conformable technology, we can create them with greater reference to broader cultural, social, and cultural context so that people are not restricted in some way by these devices that we are ultimately creating and that ultimately may go into the market and become mass manufactured, but instead that it can enable the full diversity and expressiveness of the human experience. I would like to acknowledge all of the lab members in the hybrid body lab. Each of these projects is a significant amount of work and interdisciplinary collaboration between engineering, science, art, and design disciplines. And the credit really goes to all of my students who have led and also worked on these projects. And also thanks to all of our collaborators who span a range of disciplines from medical disciplines to robotics, architecture and design, etc., for collaborating with us and expanding our views, and also to our sponsors for supporting our work. And last but not least, I would like to put in a plug for a conference that I will be hosting in collaboration with my other colleagues at Cornell. So we'll be hosting the ACM Symposium on Computational Fabrication in New York, in Manhattan this October. And for those interested in computational fabrication, I highly encourage you to submit a paper or even a demo. And so thank you very much for being here for this talk, and I'm happy to take any questions.
All right, thank you very much for the very insightful talk. I don't know if, okay, there's Eleonora connecting, so I don't know if she has a question. Otherwise, I may have one question. I don't know if the audience has a question.
Hello,
Yeah,
nice to meet
please.
you. I cannot switch on my video camera because I'm in my garden. I put it it's not the case for me to switch on the camera, but yeah, it was a very interesting talk. Thank you very much. I really appreciated everything you said. I had just one question. Maybe I'll tell you a bit about myself before introducing the question, so maybe you can understand where it comes from. So I'm doing research on fashion design, and I'm approaching now fashion designers who are doing items in order to survive in the age of surveillance capitalism, for example. So they're doing items that can hide your body parts or your face, or that are like working as a tool of resistance in times of surveillance. So I was wondering if, for example, a technology like the eyelid sticker gets into use, how would you imagine a regulation of such a device in order not for that to be used like for surveying, I don't know, workers. I don't know. I see maybe someone I can imagine a boss who wants to understand whether their workers are actually working when they're at home or something like that, and they use devices like that and they force them to wear this during the days. How do you see this scenario, and what do you think about how can we regulate that? I don't know if you have an idea about it. Thank you.
Yeah, so thank you for the question. So I think there definitely is a lot of concern, right, around where the data collected from these devices goes, right? And same with all the data that's collected from our smartphones, right, through our daily activities. Where does this go? right? And I think this is definitely a very, very important question, especially as these devices, right, they start collecting maybe even more intimate data, right? And what is a way for this data to be still in the user's control, right? However, if the person wearing it feels that it can do something useful for them, right, for still this device to still be performing. So I think that's a very, very important question. And I think there's a lot of data ethicists, et cetera, who are really examining this topic. And one thing that my lab likes to do, because these devices are so early in their development, that it will take some time for them to actually be able to be mass produced because of a lot of manufacturing challenges. And I think while I don't have an answer for this very important question, I think one very important thing to do is to understand people's perceptions. And we really try to do that with a lot of the devices that we create, thinking of having more people wear it, people from different backgrounds wear it, right? And to understand what are their main concerns, right? And so in some ways to start the conversation about this much more earlier, before these devices are actually proliferating, instead of the other way around, right? Already proliferating and trying to do something different. Yeah, but I definitely agree. This is a very, very important issue.
Okay.
Yeah, thank you.
Thank you very much, Eleonora, for the questions and for the answer. Yeah, I think we also run out of time, unfortunately, but it was very insightful and very inspiring. And we really hope to keep in touch, because I'm pretty sure there will be artists from our community interested for this conversation. And yeah, awesome. Thank you very much.
Awesome. Okay. Thank you so much for having me. Bye, everyone.
Okay. Bye. Bye. Bye.
Bye.
Bye. Bye. Bye.